In this lesson, we will study angles, and we'll start our lesson with some basic terminology. Let's start with the definition of an angle. An angle consists of two rays in a plane with a common endpoint called the vertex of the angle. Here is an illustration that will coincide with the definition. One thing I want you to notice is that the two rays are here, right? These are the two rays. This is the common endpoint called the vertex, but this is the initial side. And then this is the terminal side. And we know that because of this direction that is illustrated here by this arrow. The angle started here, if you will, and it's opening counterclockwise. It's opening counterclockwise. So it started here. This is the initial side, and then it opened up to this ray here. This is the terminal side. Now, an angle opening counterclockwise, like this diagram here, would have positive measure. Any angle that opens counterclockwise is said to have positive measure. An angle that opens clockwise would have negative measure. So this angle would have positive measure because it's opening counterclockwise, and this angle is has negative measure because it's opening clockwise. Please do notice that if this direction was not given, or this direction, if it was not given, then we would not know how these angles are rotating or how they are opening. We would not know if I just gave you this angle here without the direction that it's opening, you and I would not know whether the angle has positive measure or negative measure. Now, the most common unit for measuring angles is the degree. Degree measure was developed by the Babylonians like 4,000 years ago. So we're going to be using degree measure a lot in our course. We assign 360 degrees for a complete rotation of a ray. So all the way around, 360 degrees. Which would lead us to 90 degrees, which is 1/4 of a complete rotation. So 90 degrees is just 1/4 of 360 degrees. And 180 degrees is exactly half of 360 degrees. So 180 degrees is half of a complete rotation. Some more terminology for us. An acute angle is an angle whose measure is between 0 degrees and 90 degrees. I'm using the Greek letter theta to denote the measure of my angle. So theta, if it's an acute angle, then theta has to be greater than 0 degrees, but strictly less than 90 degrees. Now, if the angle measure is exactly 90 degrees, then we're talking about a right angle. So theta in this case is exactly 90 degrees. And we always use this notation here in yellow to denote a right angle. An obtuse angle is an angle whose angle measure is greater than 90 degrees but less than 180 degrees. And if theta is exactly 180 degrees, then it's a straight angle. Couple more definitions for us. If the sum of the measures of two positive angles is 90 degrees, the angles are complementary. If the sum of the measure of two positive angles is 180 degrees, the angles are said to be supplementary. Remember, complementary means they add up to 90 degrees. Supplementary means they add up to 180 degrees. All right, we've reached our first example. Find the measure of the complement and the supplement of an angle measuring 55 degrees. Now, if we have an angle measuring 55 degrees and we want to find the complement, that must mean we want to find the angle such that when I add it to 55 degrees, I get 90 degrees, right? That's the definition of being complementary, right? So in order to find the complement of 55 degrees, all I'll do is subtract 55 degrees from 90 degrees. And we'll identify that as 35 degrees. 35 degrees is the complement of 55 degrees because their sum would be 90. I'll do something similar in order to find the supplement of 55 degrees. Now remember, supplementary angles add up to 180 degrees. So the supplement of 55 degrees will be the angle such that when I add it to 55 degrees, I get 180. That is to say, if I subtract 55 degrees from 180, I'll find the supplement, and that would be 125 degrees. All right, very good. Let's move on to the next example. Example 2, find the measure of each angle. Here we have a right angle, so it's 90 degrees, and the measure of this angle here, this first one, is 3x degrees, and the measure of the second one here is 2x degrees. So because this is a right angle, we know that it must be equal to 90 degrees. That is to say, the sum of 3x degrees and 2x degrees must be 90 degrees. That is to say, 3x degrees and 2x degrees must be complements. So if I take 2x, that angle, and add it to the other one, I should get 90, right? So that would give me 5x is equal to 90. And dividing both sides by 5 would give me 18. So x is equal to 18. Now, I'm not done because they asked me to find the measure of each angle. So find the measure of this angle here, which is 3x degrees, and find the measure of this angle here, which is 2x degrees. So now that I know what x is, I can figure out that 3x is equal to 3 times 18, which is 54. Let's not forget the units, 54 degrees. Now 2x is going to be 2 times 18, which is 36. Don't forget the unit, 36 degrees. Now, before we box our answers, let's make sure that our answers make sense. Remember, this is a right angle, so the sum of the angle measures should be 90 degrees, and 54 plus 36 is indeed 90 degrees. So these are complements, so we are good. These are our final answers. Here's the second part of our example. Find the measure of each angle. Now, I would invite you at this point to pause the lesson, pause the video, and figure this one out on your own, all right? So go ahead and pause the video now and work this one out. All right, I'm hoping that you actually paused the video. This is a straight angle. So that must mean the whole entire angle from here, this initial side, to this terminal side here is 180 degrees. That is to say, 4x degrees plus 6x degrees must be 180 degrees. And that means these are supplements of each other. So if I take 4x and add it to 6x, I should get 180. That gives me 10x is equal to 180. So x must be 18. Now, we're not done. We have to find the measure of each angle. So 6x degrees would be 6 times 18 degrees, which is 100, 8 degrees. And the next one is 4 times x degrees. So this one will be 4 times 18, right? Degrees, of course. And this is 72 degrees. Now let's do a check really quickly. We said that these angles have to be supplements. So when I add them, I should get 180. And 108 plus 72 is indeed 180. So we are good to go. These are supplements. These are the measures of each of those angles. Good job. Now, traditionally, portions of a degree have been measured with minutes and seconds. 1 minute, this is how you denote 1 minute, is 1/60th of a degree. That is to say, 60 minutes is 1 degree. Now, less than a minute is a second. 1 second, and this is how you denote seconds, 1 second is 1/60th of a minute, which is 1/3600th of a degree. So a second is really small. That is to say 60 seconds is equivalent to 1 minute, and 3,600 seconds is equal to 1 degree. All right, our next example, perform each calculation. The first calculation they want us to perform is 51 degrees, 29 minutes plus 32 degrees, 46 minutes. To help me do this, I am going to add vertically. I'm going to stack these up. All right, so I'm going to add the minutes first. 29 minutes plus 46 minutes, that will give me, let's see, 75 minutes. Let me write that down. And then 51 degrees plus 32 degrees will give me 83 degrees. Now, this will not be my final answer because every 60 minutes is 1 degree. Remember up here, 60 minutes is 1 degree. So what I'm going to do is I'm going to take 60 minutes away from 75 minutes and convert the 60 minutes that I subtract from 75. I'm going to convert that to 1 degree and add it to 83 degrees. So here I have 83 degrees plus 60 minutes plus 15 minutes gives me 75 minutes. Now I'm going to convert this 60 minutes here to a 1 degree and then add it to 83 degrees. So now my final answer is 84 degrees and 15 minutes. The next calculation is 180 degrees minus 117 degrees and 29 minutes. All right, so let's stack this up vertically. All right, now we know that we cannot take 29 minutes away from no minutes, so let's convert 180 degrees to 179 degrees and 60 minutes. So basically take 1 degree away from 180 degrees and convert that 1 degree to 60 minutes. Now we can do the subtraction. We can take 29 minutes, from 60 minutes to give me 31 minutes. And 179 degrees minus 117 degrees is, 62 degrees. So this is my final answer. This is my difference. Good job. Now in the first part of this example, we are converting to decimal degrees. They're giving us an angle in degrees, minutes, and seconds, and they want us to put it or rewrite it in decimal degrees. So here we go. The main thing that we have to convert is the portion of this angle measure. So basically 20 minutes, we need to put that into decimal degrees, and 30 seconds. So 105 degrees is 105 degrees. Now here, 20 minutes is equivalent to 20 over 60 degrees. Remember that every 60 minutes equals 1 degree. So that's why we're dividing 20 minutes by 60 in order to get its representation as far as decimal degrees is concerned. Now seconds, remember that 3,600 seconds makes a degree. So 30 seconds will be divided by 3,600, and that'll give me my portion as far as degrees are concerned. Now we're going to round this to the nearest thousandth. So use your scientific calculator here if you need to. So our final answer is 105.342 degrees. All right, let's go to the next calculation or the next conversion. In this example, we had an angle in degrees, minutes, and seconds, and we converted it to decimal degrees. The next example is going to give us an angle in decimal degrees and ask us to convert it to an angle in degrees, minutes, and seconds. Convert 85.263 degrees, 2 degrees, minutes, and seconds to the nearest second. So the first thing I've done is 85 degrees is 85 degrees, okay? But the portion amount here, 0.263 degrees, I've multiplied that by 60 minutes. Remember, every 60 minutes is a degree. So now we have 85 degrees plus 15.78 minutes. Now what I'm going to do is I'm going to take this portion here, 78 minutes, and convert that to seconds by multiplying by 60 seconds. So now you can see, hopefully, that, so we already have 15 minutes here, and 0.78 minutes, I'm going to multiply that now by 60 seconds. All right, notice we multiplied by 60, and now we're multiplying by another 60 here. So this will give us, so rounded to the nearest second, that would be 85 degrees plus 15 minutes and 47 seconds. We can write this without the plus signs at this point. So here's our final answer. Good job, everybody. All right, two definitions for us. An angle is in standard position. This is very important. If its vertex is at the origin and its initial side lies on the positive x-axis. I've drawn two pictures for you. This angle is in standard position because this is the initial side and it lies on the positive x-axis, and the vertex is at the origin. This angle is said to be in standard position. Notice that it has positive measure because it's opening counterclockwise. This angle is also in standard position because its initial side is on the positive x-axis and its vertex is at the origin. It also has positive measure. An angle in standard position is said to lie in the quadrant in which its terminal side lies. So because this terminal side lies in quadrant 1, then this angle is said to be in quadrant 1. This angle is said to lie in quadrant 2 because its terminal side is in quadrant 2. So the quadrant that holds the angle is the quadrant in which the terminal side lies. It's all about where is that terminal side. Now, a quadrantal angle. Angles in standard position whose terminal side lies on the x-axis or the y-axis, like 90 degrees, 180 degrees, 270 degrees, 360 degrees, and so forth, are quadrantal angles. Now, quadrantal angles are also in standard position, right? Angles in standard position. What's special about quadrantal angles is that the terminal side lies on one of the axes. The next term I want us to consider is coterminal angles. Now, this is really important as well. Let me start with a diagram this time around. Here I've shown you what 60 degrees might look like. Now, this angle is in standard position. I actually didn't show you the terminal side, the initial side, but assume the initial side lies on the positive x-axis. Here, I can draw it for us. Right there, all right? So this is in standard position, 60 degrees. Now, if I do a complete rotation, and if I continue from 60 degrees all the way around, so from 60 and I go around 360 degrees, one complete rotation from 60 degrees, that would give me 360 degrees plus 60 degrees, which is 420 degrees. Now pay close attention here. The only difference between 60 degrees and 420 degrees is that they have different amounts of rotation. They have different amounts of rotation. They have the same initial side. They have the same terminal side. They just have different amounts of rotation. These two angles are considered to be coterminal. Coterminal angles have the same initial side, the same terminal side, but different amounts of rotation. So make sure you have this in your notes, all right? Here's our last example for this lesson. Find the angle of least positive measure, that's important, least positive measure, that is coterminal with each angle. Now this angle, 1,106 degrees, is more than 360 degrees. So this is what we're going to do. We are going to subtract as many rotations, as many 360 degrees as we can until we get an angle that is of least positive measure. So what you see me doing here is subtracting 3 full rotations from 1,106 degrees. Now, keep in mind that if this is too much, 3 rotations, then my answer is going to be negative, and I don't want it negative. So if this turns out to be negative, this difference, that means I took too many rotations away. Maybe I should only take 2 away, right? If I don't take enough away, like if 3 rotations is actually not enough, then I may end up with an angle that is positive, but not of least positive measure. So this is really important for you to subtract as many full rotations as you can until you have something of least positive measure. Now, 3 times 360 degrees is 1,080 degrees. So when I take 1,080 degrees away from 1,106 degrees, I get 26 degrees. 26 degrees is coterminal with 1,106 degrees, but it's the angle that is of least positive measure that is coterminal with this angle. So keep in mind that there are infinitely many coterminal angles with 1,106 degrees. There's infinitely many, but there's only one that is of least positive measure. Let's look at another example. The next one is negative 150 degrees. Now remember, you want something positive. Because this angle that they gave you is negative, you're going to add rotations. See, before we were subtracting rotations, that's because they gave you something that is really, really positive, right? Really big. This time around, they're giving you something negative, so we're going to have to add rotations. Now, don't add too many because you want the coterminal angle that is of least positive measure. I think we only want to add 1 rotation here. 1 rotation. So this gives us 210 degrees as the coterminal angle that is of least positive measure. All right, good job. Let's do maybe one more. Negative 603 degrees. Now we're going to have to add rotations again, but notice that we can't just add 1 rotation like we did in the previous example, because if we only added 1 rotation, we're still going to be left with something negative, and we want something of least positive measure. So I think we're going to want to add maybe 2 rotations here. Now I'm going to invite you to pause the lesson, pause this video right here, and would you please work this example out until the end. All right, go ahead and do that now. All right, I hope that you found 117 degrees to be the angle that is coterminal with negative 603 degrees of least positive measure. This brings us to the end of this lesson. Let me just leave you with one thing before you go. I wanted to leave you with, first of all, a list of some of your major quadrantal angles here, but also angles that are coterminal with your quadrantal angles. So 0 degrees plus or minus 360 degrees, or 0 degrees plus or minus 720 degrees, all of these are coterminal with 0 degrees, and so forth. So these are examples of 3 coterminal angles with 90 degrees. These are coterminal angles with 180 degrees, and coterminal angles with 270 degrees. Now remember that there are infinitely many coterminal angles, right? So this table just shows a few of them. All right, great job. I hope you learned a lot. I hope you took really good notes.